Okay, part 2 of this lesson for 8.9, binomial probabilities. We are going to finish with question number 4. And when we make this by probability distribution, it might be really helpful to answer these questions. It's just a way to organize the information that we've been doing on the first couple of questions. So let's look at 4a. It says, consider a spinner that is split into 6 congruent sectors. 2 of these sectors are colored green, 2 are colored blue, 2 are colored red. What is the probability of the spinner landing in green? So if you're having trouble picturing what that looks like, it's really taking a spinner and separating it into, 6 congruent parts that obviously should be in the center right there. 2 of the parts would be green, so probably those 2 parts are going to be across from each other like that. 2 of the parts would be red, so probably be across from each other like that. And then 2 of the parts are blue, so across from each other like that. And if all of those spaces are congruent to each other, then what is the probability that it is green? So probability of green, no, that's not very good color. Just keep it in black. Probability of choosing a green, well, there's 2 greens out of 6 parts, so that's a 1/3 chance. Right, so that's going to be my probability of success. I'm using the letter S for success. So if that's my probability of success, then my probability of failure, which is not green, well, that's 4 pieces out of the 6, which is, in other words, 2/3. That's the complement, right? So my failure is the complement to my success. So if the probability of success is 1/3, then the failure must be 1 minus 1/3, which is 2/3. Okay, now we're going to look at part B. It says, suppose a trial is a single spin, and the success means the spinner lands in green. If the spinner is spun 4 times, find the probability of the spinner landing in green 0 times, 1 time, 2 times, 3 times, or 4 times. Fill out the table to organize the information. So if the spinner is spun 4 times, that is the exponent you should take in your binomial expression. So we have success plus failure, and we're doing that 4 times, so I'm taking that to the 4th power. Now obviously we're going to have to expand that, so we do a little side note of Pascal's triangle. So we do the 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. How do I know to stop here? Because if it's to the 4th power, the second coefficient is the same as that exponent, so it's 4. Therefore, I know that my coefficients are going to be 1, 4, 6, 4, 1. So does that match here? 1, 4, 6, 4, 1. Yep, so we're good. So the probability of landing in green. So first we would do success, 1 success to the 4th power. And then we would do 4 times success to the 3rd power, failure to the 1st power. And then we would do 6 times success to the 2nd power, failure to the 2nd power. Go back to 4, success to the 1st power, failure to the 3rd power, and then a coefficient of 1, failure to the 4th power. So the probability that we would get the success 4 times, the spinner would land in the green 4 times in a row, 3 times in a row, 2 times in a row, 1 time in a row, 0 times. So now you just plug in the information to get your decimal equivalent. So success, we just said, was 1/3, so it's 1/3 to the 4th power, which is approximately 0.0123. For the second one, success is 1/3, failure is 2/3, so you have to multiply all that out, and you would get something around 0.0988. 6, success is 1/3, failure is 2/3, so we have to multiply 6 times 1/3 squared times 2/3 squared. You should be trying this on your calculator. If you want to stop and pause and try all these on your own, you could do that, and then check your answers. So you should have gotten 0.2963. Remember, I'm not always right, so I might be making an error here, so you want to check it. So the 4th one, where we have 1 success, 3 failures, we have to do 1/3 to the 1st power, 2/3 to the 3rd power, multiply that out, I get approximately 0.3951. And then for all failures, so that's 2/3 to the 4th power with a coefficient of 1, which I don't need to put there, and that's a 0.1975. Okay, so what does that mean? That means to get 4 greens in a row, that's only about a 1% chance, right? If you move the decimal place 2 times to the right, it's only a 1% chance. To get 3 greens, then you would have a 10% chance approximately. To get 2 greens, it would be about a 30% chance. To get 1 green, it would be about a 40% chance. And to get no greens, it would be about a 20% chance. So sorry, 10%, 30%, 40%, and then a 20% chance here. Now, why might that be useful? I didn't do a follow-up question here, and I should have. It says, find the probability of the spinner landing in the green sector 0 times. That would be this probability, 1 time, this probability, 2 times, this probability, 3 times, this probability, 4 times, this probability. So I might ask you a question, find the probability of the spinner landing in the green sector at least 2 times. So the probability of it landing in green at least 2 times. So what are you going to do? Well, if you have it organized in this fashion, right, at least 2 means 2 or more. So that means you would add the 0.3951 plus 2 or more. Oops, sorry, that's not right. See, there's my mistake. 0.3951 is only 1, right? So I started with the wrong one. So at least 2 times. So it would be 0.2963 plus 0.0988 plus 0.0123. So then you can see whatever that total is would be the taking into consideration at least 2 times, which means 2 times, 3 times, or 4 times. And then you would find that total. Okay, what if I give you a graph of a probability distribution? You should know how to then translate this into a graph, right? So we have to go across here and decide, well, I would go from least to greatest. So this is 0 successes, 1 success, 2 successes, 3 successes, 4 successes. And then look at your probabilities. So 0.1, 0.2, 0.3, 0.4, that makes sense to go up by 0.4 because that's the highest we have is 40%. So 0.1, 0.2, 0.3, 0.4. Right, so I'm just transferring this information into this chart. So 0 successes was about 12%, or sorry, 1%, my fault. Again, error. 0 success is back here. I'm looking at the back because I'm going backwards now, right? This one is pertaining to this right here. 1 success, that is about 40%, so I'm going all the way up here. 2, I have about 30%. 3, I have about 10%. Oops, too high. And 4, I have next to nothing. So 1%, which is right down here at the bottom. So that is your chart for your probability distribution, your graph with your results. So if I gave you this graph, you should be able to tell me what that means, or if we calculated those results, you should be able to create the graph. If you have questions, please ask me in class. Okay, moving on to our final question. It says, a traveling magician noticed that 12% of the balloons he uses for his balloon animals pop. So 12% pop. If he has 6 balloons, what is the probability that exactly 4 of them will not pop? Okay, so if they don't pop, that means they stay as a balloon. So I said 12% of the balloon animals pop. So is that success or failure, I guess is what you want to decide. So I would say that's your failure, that it doesn't stay popped. So your probability of success, your probability of failure. So I'm calling a failure the fact that the balloon pops. So the balloon pops is my failure. So it pops 12% of the time, so that's 12 out of 100, right? Or you could just make that a 0.12, or you could reduce that fraction into 3 over 25. It doesn't really matter. So I'm probably just going to use the decimal because it's a little easier. So if my probability of failure is 12% or 0.12, then my probability of success is 1 minus that, right? Or the rest of the remaining percentage, which is 88%, or 0.88. Now, it says exactly 4 of them will not pop. So I want my success to be to the 4th power. Okay, good. Well, if the success is to the 4th power, that means failure is to what power? Okay, let's reread the question. So the traveling magician noticed that 12% of the balloons he uses for balloon animals pop if he has 6 balloons. So if he has 6 balloons, that is the exponent. So that's success plus failure to the 6th power. That's how many he has. So if 4 of them stayed without popping, then 2 of them popped. So my exponent on my failure is 2. Okay, but remember the last thing we have to do is find the coefficient in front of it. So how do we find the coefficient? Well, remember this is your n, and then whatever this number is here is your k. So it's 6, choose 2. So now just do all that calculation. So maybe you want to pause, grab your calculator, do the calculation. You can use your calculator and just punch in 62, or you can do the formula. But then you have 0.88 as my success, I have 0.12 as my failure, so I get approximately 0.1295. So what is the probability that exactly 4 of them will not pop? So that's about a 13% chance that 4 of them will stay inflated and will not pop. Okay, so again, remember this might be on the quiz, but you will get to use these notes. So if you've taken notes and you can find the probability of success, probability of failure, and you understand Pascal's triangle, then hopefully it won't be an issue and you can refer to this. We can review a few minutes before, so please, if you didn't understand something in one of these 2 videos for 8.9, make sure you ask. I can go through it, and then we'll take the quiz. Okay, hope you had a nice weekend, and I will see you soon.